When we motion palpate for occiput, we always perform extension first, lateral bending second, and rotation last. If you remember, when we motion palpated C2 to L5, we actually flip-flopped the lateral bending and rotation. We did rotation second and then lateral bending last. The reason why is that the segmental contact point from C2 to L5 is the spinous process. For occiput, we're going to be using the mastoid process and also C1 transverse process. Occiput, consider it like a bowl. It's like a little bowl that sits on top of the lateral masses of C1. So when we do extension, remember, we're going to be compressing down on the patient's top of the head. We're going to be rocking occiput forward in a P to A glide. So what we're doing is, by putting that pressure, is we're locking in all of the cervical vertebra, and we're isolating this segment right here between the condyles of occiput and the lateral masses of C1. So as we're pushing down, if we do not have a good P to A glide, we say that occiput is shifted posterior. When it shifts posterior, it actually rides up superior. So the first two letters of our occiput listing is going to be posterior and superior for extension. For lateral bending, there's three ways to do lateral bending. We can do it very similar to extension, where we're placing or we're pushing down on the patient's head, but this time we're going to be laterally bending to the one side and rocking the patient's head forward. And then we're going to actually laterally bend to the opposite side, press down, and rock the patient's head forward. The other way that we can do lateral bending, or check lateral bending, is to use the segmental contact point of mastoid and the C1 transverse process. So we consider that a dual contact. When we do that, we're going to lean the patient's head to the side, and we're going to see if mastoid and C1 approximates or comes together. If it does not, there's a lateral bending issue to the side. The last way we can do that is through a single hand contact or a single contact. And what we're going to do is just basically place our finger in between mastoid and C1 TP. Lean the patient's head to the side, and you should feel it pressing down onto your fingertip. So if any of them, if there's a restricted motion on any of those, we say that occiput has shifted laterally to that side. So for example, if the occiput shifts to the right, it's going to shift to the right, and it's going to ride up on the lateral mass of C1. And we're going to say it's shifted right and superior. Okay? So for lateral bending, there's our second two letters. Now this is going to be our frame of reference. This is the side that we're going to adjust the patient. So when we go to adjust the patient, adjust this listing, we're going to be standing on the right side. So on that right side, we need to check for rotation. So when we check for rotation, that's going to be our third two letters here. We're looking to see if occiput has shifted on that side anterior or if it's shifted posterior. So on the side of laterality, we're going to place one finger on the mastoid process, the other finger on C1 TP, and then we're going to rotate the patient's head in the opposite direction. So we're looking to see if occiput is gliding and separating away from C1. If it does not glide forward and separate away from C1 on the side of laterality, we say that occiput has shifted posterior on that side. It does not want to move from posterior to anterior. So on that right side, we're going to say occiput has shifted or rotated posterior. So whenever we have a fixation on the same side of laterality, we're going to say that occiput is shifted posterior. Let's say there's no rotation fixation on the right-hand side. Remember, with rotation, we always check it bilaterally. So we're going to go ahead and check it on the left-hand side. So we're going to place one finger on the mastoid, one finger on the atlas TP, and we're going to rotate the patient's head to the right. When we rotate to the right, we notice there is a little bit of fixation. mastoid does not want to glide on top of C1 on that side, so we say that occiput on the left-hand side is rotated posterior. However, laterality is on the right side. So if occiput is rotated to the left, posterior, it must rotate anterior on the right. So we're going to give those last two letters a right anterior. So for atlas listings, the first two letters can only be determined by X-ray. The first letter is always going to be A for atlas or anterior. Atlas will never shift posterior. Why is that? The reason why is because the dens is in the way. So atlas can never subluxate posterior, it'll only subluxate anterior. The second letter has to do with the position of the anterior tubercle. So when we take a lateral X-ray of the cervical spine, the anterior tubercle is either going to be measured in a superior position or an inferior position relative to occiput. So the second letter is going to be determined by the position of the anterior tubercle on a lateral X-ray, either superior or inferior. I'm going to go ahead and just write S for superior for example's sake. So the third letter is for lateral bending and the fourth letter is for rotation, very similar to occiput. The only difference is that the segmental contact points change. In this case, instead of using mastoid in C1 like we did for occiput, we're going to be using the C1 transverse process and the C2 transverse process. So, same thing as occiput. We'll place our fingers on C1 and C2 TPs, and then we're going to laterally bend our patient's head to the side, and we're going to feel for the TPs to approximate. If they do not approximate, we say that atlas has shifted right or lateralized to that side. So I'm going to give it an R. Now, on the side of laterality, that's the side that we're going to adjust, the right side. We want to find out, did atlas rotate anterior on that side or did it rotate posterior, if at all? So we place one finger on atlas TP, one finger on axis TP, and then we rotate our patient's head away from our fingers to the left. If atlas does not glide away from axis on left rotation, we say that atlas on that side is stuck or fixated posterior. So we're going to give it a P for posterior. So our listing then for atlas is anterior with a superior tubercle, lateralized to the right, and posterior on that right-hand side. So let's say there's no rotation on the right-hand side. We always have to check rotation bilaterally. So when we check rotation on the left-hand side and we rotate to the right, we notice that the left-hand side there's a fixation. So we say on that left-hand side is posterior, but on the side of laterality, it's gone anterior. So on the side of laterality, we're going to say that it's A for anterior.